Hello, I am Umkar. So today I am going to tell you about the optimization of loss function and regression line using the gradient descendant. So one of the key techniques of used in the data analytics and machine learning to improve the model performance are the optimization of loss function and regression line using gradient descendant. So second, understanding of regression. So first is statistical prediction method, in which regression is fundamental statistical and machine learning technique used to predict the continuous output values by identifying the relationship between the variables. So regression is a statistical and machine learning method which is used to predict the continuous output of values. It helps to identify the relationship between the independent and dependent variables. So it is basically help us to understand the relation between two um, variables such as independent and dependent. Example such as the predicting sales and product based on the amount of spend on advertising. Second is like independent variable is X and like the advertising budget, and dependent variable is Y, like the sale revenue. That goals is to find the line and curve that fits the data points and most accurately. So independent variable X advertising budget, dependent variable Y sales revenue. So goal is to find the fitting line between line of the curve. Third, plotting the data sales versus advertising. So this data set demonstrates in positive linear relationship between the advertisement expenditure and the sale revenue, forming the basics of our regression analysis. Here are two columns in which we are seeing the advertising increase and sales and rupees. So here the data given for 10, 35, 20, 30, etc. Mm. So the slope of this is m is equal to, we are following the equation of regression, which is y is equal to 1.0.5, which is the slope, into x plus 24.5, which is the average. So slope is equal to m is equal to 1.0.5 for every 1,000 increases at sales growth by 1,050. Also, intercept C is equal to 24.5 base lengths even with no ads. So basically, this table shows us the positive linear relationship as ad spending increases, sales increases. So the regression line helps to predict the future sales based on the ad budget. So what is the loss function? So the loss function measures the difference between the predicted values, actual values. It tells us how well our model is performing. The smaller the loss, the better the model. So common loss function means the squared error, MSE. So here are the formula of MSE, 1 by n, summation of y prediction minus y actual bracket square. So this is the most common loss function. So our objective is the minimize loss to achieve maximum prediction accuracy. So the loss function is like a scoreboard. It tells us how wrong our prediction are. Our goal is always reduced to the score to the lowest possible value. Fifth, our concept is optimization concept. So first, parameter adjustment. So parameter adjustment. Optimization involves systematically adjusting the model parameters like the slope, intercept. So as regression equation is equal to y is equal to mx plus c, where the m is slope and c is the intercept. So here we are taken the parameter as we can see in this PPT. Optimization involves the systematic adjusting model parameters like m slope and intercept c to minimize the loss function. As we know, the minimize the loss function as it is the better algorithm. So second, finding the best fit. So the process continues iteratively until the regression like achieves the most accurate fit to data point, which is the minimum loss function value. So third is performance improvement. Each optimization step brings the model closer to optimal performance and prediction accuracy. That gradient descendant, the key optimizer. So first is the initialize the parameters. Start with the random values for the slope m and intercept c as the starting points. So this helps us to get the independent and dependent values. Second is calculate the loss. Compute the current loss using the loss function to measure the predicted error. Third is compute gradient. Determine the direction of steepest increase in the loss function. Fourth is the update parameters. Move in the opposite direction of the gradient to reduce loss. Control by running sigma. So gradient descent is an algorithm used to minimize the loss function. And these are the four steps for it. Initialize the parameter, calculate loss, compute gradient, and update the parameters. So repeat this until the loss becomes minimal. Learning rate, control how big each step is. So in summary, the gradient descent keeps us updating uh, slope and the intercept after every step. The learning rate decides the how fast and slow the updates happens. If the learning rate is too high, it may overshoot the minimum. If it is too low, it will take too long to reach it. So how gradient descent improves regression? Initial initial random line start with a poorly fitting regression line based on the random parameters. Secondly, iterate the refinement. Each iteration slightly reduces the error between the predicted. Third, convergence. The line gradually becomes more accurate through continuous parameter updates. Fourth, optimal solution. Finally, reaches the best possible regression line with minimal loss. So in this, as you can imagine, it is like climbing down a mountain blindfolded. Each small step takes us closer to the lowest point, which represent the minimum loss. Real life applications. So here are three real life applications. First is the financial market, like the stock market, in which we are predicting the stock prices and market trends. As you know, stock prices are very volatile, can go up, upward trends and downward trends depending on the market conditions. Secondly, algorithm trading strategies. So there are various strategies like we are using EMA, average, etc., and various indicators to predict what will happen in the future for the stock markets. Third is the risk assessment model. So second example is weather and climate. Mm. So first, weather forecasting models, climate change predictions, natural disaster warnings. Third real application is healthcare, medical cost estimation, patient outcome prediction, drug discovery optimizations. So in summary, it is like predicting tomorrow's weather, estimating medical bills, suggestion next movie, gradient design helps models learn and adjust the automatically for the better accuracies. So in conclusion, gradient descent and transformation draw data into actionable insights through the continuous learning and optimization, like machine learning principle. The fundamental technique enables the regression model to learn data from systematically minimizing prediction errors, ultimately finding the optimal regression line that is best represent the underlying pattern in the data. So in summary, the it is the gradient descent is fundamental technique for the model optimization. It helps the regression model to learn continuously, minimizing the loss in function through repeated updates. It finds the best fitting regression line, improving the accuracy performance. It performs the core machine learning, allowing model to learn data from efficiently. So thank you. That's it.